Hello, my name is Andrei, and I want to give you a quick introduction about myself and about a project I built during the course of the last week. I spent most of my career building SaaS platforms and digital products. I'm a product engineer. Most of my experience is in actually backend engineering, and I don't have experience in programming languages nor in compilers. Nevertheless, I decided to give it a shot and try to apply to this role because I listened to a podcast, Preslav and Logichkin, a few weeks ago and got quite fascinated about the ideas that Andrei presented in the podcast. And I also like programming languages in general. I worked with a bunch of them in the past, from Ruby to C Sharp. And now I use AI tools also to help me and my teams build products our customers love. But I always enjoyed working on libraries, infrastructure, and improving developer velocity. So this is another reason why I decided to apply. And I took this opportunity to learn something new as well, because I haven't built anything for EDE or code editors in the past. And closing this gap was quite interesting to me. So I choose docstring-verifier as a project that I can implement and present to you. And on the screen, you actually see the GitHub page of that project. I highly recommend you to skim through the README file because it explains a bunch of the decisions that I've made. And also, it has high-level overview of the extension, as well as how you can test the extension on your own machine. Basically, you would just need to install Node.js, Visual Studio Code, and as well as PNPM tool, which basically just more powerful NPM alternative. I already installed all the dependencies because I work on that project, but we can run the test and see whether they pass or not. This is probably the second step I recommend you to do to make sure that everything works in your machine. And we see that more than 357 tests have been passed. And we also saw that while we run the tests, a new instance of Visual Studio Code appeared to us. And this is how actually we test the extension with a bunch of unit integration tests. So what else you should know? Because implementing the docstring analyzer and quick fixes in Visual Studio Code for different languages is, in my view, not a easy job in such short period of time. I've decided to focus on only one language, which is Python, but make the extension extendable for other languages and for other docstring styles and Visual Studio commands. But so besides supporting Google and Sphinx format, I also implemented one quick fix action for missing function parameters. And I also did integration with GitHub Copilot because this usually AI tool that people have when they install Visual Studio Code, and you don't need an additional API key from OpenAI, or Claude or something else. Everything should work out of the box. But if you clone the repo, run the extension, and something doesn't work, you can always look at the debug console and see all the log messages that I left in the code to troubleshoot the solution. For example, let's manually test the extension with the examples that you can find in this folder for the Python programming language. So to test the extension, as I said, you have to install all the dependencies with pnpm or npm, and then you hit F5, and Visual Studio Code will spin a new instance for you, and then you can open one of the examples, and you can see that each of the example is named after some check or analysis problem. So for example, here, if we open this file, we see that parameter x is actually missing in the doc string, but it's present in the code. And we can try to fix it using the code quick fix action. So if we do this, we immediately get the placeholder, and that placeholder will be fulfilled by GitHub Copilot if you have it enabled on your machine. On my machine, it's enabled, and I think for most people, it should be enabled by default, if I'm not mistaken. But anyway, so we fixed one problem, and there are two more problems in this document, in this file. So if we open other files, like let's say this one, we will see a bunch of problems related either to missing things that are side effects or something else. I haven't implemented fixing those for now, but again, if we want to fix this in the future, we can do this by extending the current implementation. So what else? Yeah, just play with examples and see how it goes. And there's also a README file that explains each of the example. And to show you another docstring format, here we have a Sphinx docstring, and we also see that actually there is something wrong with the return, because we see there is no return information in the docstring, but the function returns a sum of two function parameters. That's it for the demo, and let me give you some information about the system design. So the first thing that you can check is the extension file. It's basically the entry point to our extension, and this is where we plug all supported languages. You can see that if you open, for example, the languages folder, there is types file, and that types file includes a bunch of interfaces, and you can find lots of interfaces in the code because it's how I make the code extendable. So even here, if we want to, for example, plug a new programming language, we use those interfaces, and then we add, for example, Python support. We can later include TypeScript, JavaScript, whatever we want. And the next step will be enabling LLM if it's your editor, code actions, register some providers, and so on and so forth. So and if you look at each of the folder, you'll probably understand what's going on there. So analyzers just defines a bunch of Python checks. Code actions is for fixing code. What else? Generators right now is empty because I don't support such thing for Python at the moment. LLM actually provides you an integration with GitHub Copilot. And I do some things like caching here to make sure that we won't hit Copilot limits. And the main bottleneck, I would say, in my implementation right now is how I run Python code. I haven't implemented um, Python file parsers in the, I would say, usual way. I just run Python in a sub process. And for that, I use UV, which is uh, a cool tool in Python for managing dependencies, running Python scripts, and whatnot. And right now, running Python to produce AST and then serialize it to JSON, which I work with in TypeScript, can take up to maybe half a second. And for big files, maybe it won't be an issue. So there are definitely many points of possible optimizations in the extension, but my goal was first learn how Visual Studio Code extension work and how I can, implement things like quick fixes, how I can do something with programming language, Python in my case, and so on. Yeah, so give it a try, and I will be happy to discuss the implementation with you in person. Thank you for your attention. Have a good one.